let's pause for a moment and think about what we have learned so far. We learned about exceptions. We learned about exception handling. The catch will specify requirements. On the one hand, we know about exception handling. On the other hand, we learned about how to do automated unit testing using JUnit assertions. And we put these two orthogonal aspects together and see how they can interplay together. And that's why we actually develop JUnit test cases, which can either test for legal usage or test for illegal usage. In both cases, exception might occur, but depending on which case you're talking about, an exception occurring may either be expected or unexpected. Right? That's what we have learned so far. And what I want to do now is to lift all of us about 35,000 feet above the ground and think about how we can apply all these into the practice of your Java coding developments. And what I'm going to talk about, called test-driven developments, does not apply just to Java programming. If you're programming for Python, for C#, for some embedded system, for any safety critical software, this is really the very highly recommended practice for software engineers to actually apply. All right, so let me now go over with you about the workflow. I just want to visualize the workflow for test-driven developments, especially for regression testing. And then off you go. You have to just adopt that practice as much as you can. If you got any trouble understanding the critical steps of that, you can reach out to me. All right, so that's the visual workflow or flowchart about test-driven developments. I'll go over the diagram together with you in just one moment. Let me go over just a few points just to have some high-level idea. So what you want to do is to maintain a collection of test cases or collection of JUnit test classes. In each test class, you got a collection of JUnit test methods, which define the correctness of your Java classes under developments, or we say cut over here. Okay, notice one thing here. Correctness is really a relative notation, meaning that there's never an absolute notion of correctness. Correctness is usually defined by the test cases either you're given or the ones you have developed yourself. So the more test cases you can really build for testing your software, the higher the assurance or confidence you can have about its correctness. Realistically, you can almost never ever claim the absolute correctness of your software because the combinatorial explosion on the variable ranges. Well, let's say if you only got one bounded counter with only from 0 to 3, it's very easy to test exhaustively. But in reality, if you got so many variables, as those variables are simply unbounded, and then in that case, you can easily run into the case where you just don't have enough test cases, never ever. Okay, so we just want to talk about we just want to have just enough test cases to cover a reasonable amount of aspects of our software. That's something I want to remark verbally first. Okay, you want to derive and run test cases as soon as your classes under development is actually testable. Right? So what do I really mean by testable? As soon as you declare the methods header and also you develop some implementation, even partially, you should really start testing the expected value versus the return value of your methods. That's what I meant by as soon as possible. A Java class is testable when they are defined with method signatures or headers, right? But of course, if you really feel more comfortable to really develop a little bit of code on the method before you do the testing, that's also fine. But try to keep this in mind. You don't really want to develop more than one or lots of or simply a number of methods before you actually go for the testing the first time. It's too late. Okay. You want to do it incrementally. Incremental development is really is always the way to go if you want to solve some very large scale project problem. Okay, if you get a red bar, so that means your test under development or test under test, your classes under test is actually problematic. In that case, you really want to fix the errors until you get a green bar. If you get a green bar, again, you don't want to be too satisfied because it really depends on the quality or the coverage of your test cases. In the laboratory exercises, for example, the starter tests that are usually given to you is reasonably complete. However, you should also really try to test for those missing cases which are either intentionally or I did not intentionally to miss, right? That's something I want to mention in the slides. And let me now go to some visualization, and then we are done for the module. And I'll give you some advice about what you should really do beyond this lecture. Okay. So we talk about test-driven developments, right? That means your development is really driven by a list of tests. Okay, so what we are talking about is, let me put it here. Okay, let me just make it thinner. The list of test classes and also methods in the JUnits defines the correctness criteria for your software. Right? So here the key word to note is the correctness criterion, meaning that passing all of them you can more or less you can say that your software is correct with some confidence. Okay. However, the competence is predicated upon two factors. Number one, the quality of the test, and also number two, the coverage of the test. Right? You want to make sure you cover as many aspects of your methods as possible, and also the quality of test, meaning that each individual test should only test for one single aspect of your system whenever possible. Right? So that's something I want to mention first about test-driven, this part here. Okay, and then we want to talk about something specifically called regression testing, right? Let me give you a little bit of idea about where this term comes from. That can give you a little bit more maybe intuition about how this should be performed. Regression testing, okay? I guess maybe for those of you who didn't hear about regression testing, maybe the first time you heard about this term regression is when people talk about reading, maybe back in your grade school, okay? Maybe like my teacher, usually teacher will tell you that whenever you're doing some reading for the book or for some article, right? So we talk about reading a book or reading a paper. You got so many lines over here on a single page, right? So many lines. And let's say the way you read the line is by saying, I read this line here, I read this line here, and on the halfway through reading this line, I thought, I forgot about what I read in the first two lines. Maybe I should simply just go back and reread it. And then I'll reread again, and go to here. On the halfway through, more than halfway through the page, I forgot what I have read previously. So I should really go back and then go back and read it again. So regression in terms of reading is a very inefficient way for completing your assignments. So regression is a no-no in case of in the context of doing reading for yourself, which we totally agree. All of us, you should really try to read as much as you can in one pass, get a rough idea, and then if you really want to read it again entirely, you can do it, rather than just going back and forth so often on your way through. It's just so inefficient. Okay, that's about the idea about regression. Okay, let me put a regression here. So that's about regression. Regression is not a good idea. However, in the case of testing, in the context of testing, regression simply means running and rerunning. Running the same set of test cases over and over. And if you try to, if you remember, all the test cases define the correctness criterion. So whenever if you run the if you run the same test cases over and over again, so the consequence is you are reassuring the correctness of your software over and over again, which is a good thing. Okay, that means you're reassuring the correctness of your software over and over. And this is definitely something you want to do. I'll put a check mark rather than cross in the case of reading, right? So let's just get the terminology clarified before I go through the workflow, which is incredibly simple. But to really put it into practice, it does take some persistence, and also you have to really convince yourself you should really go ahead and do testing as soon as you start your code is testable. Okay, let's now go over the flow. Let's start with this box over here. We talk about Java classes in general. It could be multiple, it could be a single one. For example, the counter class that we have been doing as a running example for this module. So this is so-called the class under developments or class under tests. Okay, so the D over here is for developments, and the T over here is for under tests. Okay, either way, so sometimes I might say cut, sometimes I might say cut, right? But maybe I'll simply just spell them out. So classes under developments or classes under tests, right? It's really important to know that you never, for realistically scale projects, you will never just say seal the deal and say I'm not going to extend this project anymore. It's very common that throughout over the course of time, you may have to either extend or maintain your projects, right? So what do I mean by each one of them? So when I say extend, so that means to add new features. Add new features of your application. And over here, features, in the case of Java, it could be classes, it could be methods. Okay, so that's about the extend. What about maintain? Maintain here is also very important, right? Maintain could be, you may want to say, you want to do so-called refactor, which is to improve the internal structure of your code, whereas it should remain to be correct. So you can think about improve the structure, especially internal structure of your code. And we wouldn't really talk about refactors so much in this course, but something that should be covered in your more advanced senior level software design course. But let me give you one example. One very common refactor you may want to do for your code is, let's say you saw lots of duplicates for the for your methods, and the same block of code is being reused. So it's duplicated in so many places. So we talk about in the review tutorial series, what should you do when your code smells? You should really introduce new helper methods and let all the duplicates be replaced by the call to the same helper method, right? In that case, you want to make sure if you do the maintenance, that's really to do the refactoring of your project. You want to make sure even after the helper method is introduced, your project remains to be correct. Okay, so now refactor, one example could be, let's say, helper method. That's just one example. Okay, and then it could be for refactor, or it could be simply for the reason of bug fixes. If your customer actually report any bugs when they try to use your software, and then you gotta fix them reasonably quickly, right? You always have to under certain time pressure for sure when you do the bug fixes. And as soon as you're done with the bug fixes, what will be the best way to really make sure you don't really introduce new bugs when you try to fix the old bugs, right? So the principle over here is don't introduce new bugs while fixing old bugs. This happens very often, so don't feel bad if that happens to you. It happens to everybody, right? New versus old. And what's really the best way to know that I'm really introducing some new bugs when I fix the old bugs? Well, you got to run the regression tests, meaning that you have to make sure you rerun the same test cases over and over to make sure they always pass, always see the green bar. Okay, let's go a little bit further with a diagram. Okay, so that's the classes under test or under developments, and then as soon as you believe your code is testable, you should really derive the test cases. And one idea I just gave to you earlier was about using a state transition diagram like this, right? That's what I spoke about, right? Let me just go back to the last page over there. Okay, sorry. Let me just go back to here. All right. So let's now see how once you derive the test cases, you should really derive as much as possible. Okay. So this will be the definition of correctness of your software. So you can see this is really the correctness criteria that I was talking about over here. So you can think about this box over here really talks about correctness criteria, right? In the case of the counter problem, if you go to let me go back to Java perspective, you can see under here you can see the tests. So far I got only if you see the outline view, I only got 1, 2, 3, 4, and 5 test cases, which may or may not have exhaustively tested the software, but at least it's my notion about correctness so far. Of course, this test over here is useless, so I'm not including it. In your case, you really add as many as possible. Okay, so far we have covered these two, right? So far, okay, these two. Let's see what's going to happen. As soon as you have some test case and also some developments of your method, you should really run the JUnit test cases, right? You're going to run it as Java application. So what's going to happen is, let me use this. You're going to run these two together through the JUnit framework, right? It's going to tell you either give you a red bar if at least one test case actually failed, or it's going to give you a green bar if every one of them is actually has passed, right? Let's talk about different cases. If you actually fail some test case, in case you actually fail, which will be this root over here, in case you actually fail over here, and of course you want to fix the Java classes under test when some tests fail, right? You can think about this part of the maintenance over here you got to do when you do the bug fixes. Maybe sometimes it might involve some extension as well. I'm just saying in general, when you do bug fixes, it's part of the maintenance job you have to do over time. And then, of course, once you did the fixes over here, and then you have to rerun the test cases when you are done with the fixes. Make sure you don't really introduce any new bugs. Make sure. All right, that's about the case for getting a red bar. Equally importantly is when you actually get a green bar. So what should you do? If you get a green bar, let's say you follow this route over here, all the test cases actually pass. In some way, that's good because you don't need to fix any bugs. However, I would say, given that we said that is the correctness criteria is really about how confident you can be to actually claim that your software is correct, even though you get a green bar. So the criteria will be you want to make sure the quality of the test is really good, and also the coverage of the test is really good. So in case of the coverage, you may want to consider adding more test cases to your JUnit test package, even if you got a green bar. Okay, so let me just say this. Coverage of tests over here. So now, even if you actually get to this particular route, you still want to add more tests to cover missing cases, or maybe larger input. Let's say the existing test methods only deal with array of size 3. Maybe you want to deal with array of size 10, right? Just make sure all of them will work. Or larger input sizes, right? So that's also something you want to keep in mind. All right, so that's about test-driven development. Let me recap once more. Test-driven development is really boils down into the idea about regression. Regression simply means you want to run the same set of test cases which define the relative correctness criteria for your classes under development. And then you want to make sure for whenever you extend or you maintain, as soon as your your classes and method become testable, you want to rerun the JUnit test cases over and over and over. That's really the practice I would like you to adopt. All right, so that's about the end of this module about test-driven developments. I would like to go over just one more slide with you. What should you do? Two more actually. For the resources, you can go to the official site for JUnit 4 and see more information about assertions and JUnit tutorial example. But I believe what we have covered in this current module and in the tutorial review tutorial part 1 and part 2, we have seen many examples already. It should be more than enough. Okay, beyond this lecture, similar to the earlier module for exceptions, I want you to play with the source code that I made available to you. You can see I went over basically every one of them with you throughout the module. I want you to play with them to really set a breakpoints, launch the debugger, and change the input values and play with them. I think that's really the best way to ensure or reinforce your understanding. Okay, change the input values so as to explore the normal and abnormal execution path, right? In this module and the previous one, it's so important to emphasize the clarity of execution flow, either normal or abnormal. All right, that's about it. Stay tuned, and then we'll come for the next module very soon.